We are taking this question from the September 2020 Kzn. In the sketch below, AB is a diameter with the coordinates of A being 3 is to 2, B negative 5 is to 4 of the circle ABC. If AB is a diameter, then that is equal to 90 degrees because it is an angle in a semicircle. M is the center of the circle. BC produced to meet AT in T. The coordinates of N is 2 is to negative 2 is a point on the line TA. C is the y-intercept of the circle. 4.1. Determine the coordinates of M, the center of the circle. From here to there, that's R. From here to there, that's R as well. So it means that M is the midpoint of AB. The x coordinates of M will be negative 5 plus 3 over 2. And then the y coordinate of M will be equals to 4 plus 2 over 2. So this is equals to 3. And that is negative 2, so negative 1. The coordinates of M is negative 1 is to 3. 4.2. Write down the equation of the circle in that form. X minus P squared plus Y minus Q squared is equals to R squared. This value right here represents the X coordinate of the center. And that Q represents the Y coordinate of the center. I already know that the coordinates of the center is minus 1 is to 3. So the only thing I don't have is the R. We said that the length from here to there, that's our R. And since I have the coordinates of M, I can calculate R. So let's just say BM squared should be equals to x of M minus x of B squared y of M minus y of B squared. BM squared, that's R squared. The x of M, that's minus 1 minus a 5, which is positive 5, plus y of M, that's a 3 minus a 4 squared. Negative 1 plus 5 squared plus 3 minus 4 squared. Let me just double check. It's a minus 1 plus a 5 squared and then 3 minus 4 squared. I'm getting a 17. So the equation is, so this is going to be a positive 1 squared plus y minus 3 squared, which is equals to 17. 4.3. Prove that TA is a tangent to the circle at A. If I can prove that that is equals to 90 degrees, therefore TA will be a tangent because of the diameter perpendicular to a tangent. And how do I prove for perpendicular lines? We say we take the gradient of the first line, which is AP, multiply it with the gradient of the other line, which is AN. The gradient of AB is going to be a 4 minus a 2 and then minus 5 minus 3 multiplied by the gradient of an, which is a 2, minus minus, which is plus, and then this is a 3 minus 2. 4 minus 2, that's a 2, minus 8 multiplied by 4 over 1. So this is negative 1 over 4 multiplied by a 4, which is equals to negative 1. Therefore, AB is perpendicular to AN. And this is because the gradient of AB multiplied by the gradient of AN is equals to negative 1. Therefore, TA is a tangent. And this is because of the converse of diameter perpendicular to a tangent. 4.4. Determine the equations of the line TA. The gradient of TA is equals to 4. And this is from here. Because you can see that T lies on that line. So we can just use the coordinates of A and N to find the gradient. So this is y is equals to 4x plus c. And then we're just going to substitute a point. So I'm going to choose the coordinates of A. That's a 2, 4, 3 plus c. C is equal, that's a 12, so it's a minus 10. Y is equals to 4x minus 10. 4.4.2 BT. Okay. In order to find the gradient of a line, I need 2 points. And right now, I only have only one coordinate. I don't have another one. So I can't really find the gradient of BT. Let's try and look for another way to find. I know that this is equals to 90 degrees because we said that C is 90 degrees because it is subtended by diameter AB. So if I can find the coordinates of C, I can calculate the gradient of AC and then take those two and equate them to negative 1, the product of those two. Okay, so C is the y-intercept of the circle. I'm just going to take, this is x plus 1 squared, y minus 3 squared, which is equals to 17. For y-intercept, set x equals to 0 because they told me that C is the y-intercept. So this is 0 plus 1 squared plus y minus 3 squared is equals to 17. Y minus 3 squared is equals to 16. Then I'm going to take the square root of both sides. So y minus 3 should be equals to plus minus 4. Y minus 3 should be equals to 4, or y minus 3 should be equals to negative 4. So y is equals to minus 7, or y is equals to negative 1. So let's check here. You see the y value there is negative 2. And I can see that this line is above n. So the y coordinate there should be greater than that of n. So the coordinates of C, that is 0, is to negative 1. excuse me, now I'm ready to calculate the gradient of AC. Let's start with saying ACB is equals to 90 degrees. It is an angle in semicircle. And then now I'm just going to take the gradient of AC multiplied by the gradient of BC. These two should be equal to -1 because I've proven that AC is perpendicular to CB. Well, not really proven, but I can tell that this is 90 because it is an angle in the semicircle. And then the gradient of AC, we will say 2 minus, so this is a +1 because I'm going to take that and this. Then over 3 minus 0 multiplied by the gradient of BC, -1. Therefore, the gradient of BC is equals to 2 plus 1 over 3. So this is -1 over 3. This is -3 actually, because this is 3 over 3. Let me just 2 plus 1 over 3. So that is a 1. That is going to be a 1. Making mistakes here. Let me just say 3 over 3 multiplied by the gradient of BC, which is called -1. So this 1, -1. So the gradient of BC is equals to -1. And then now I have that -x plus c, and then I have a point on that line. Then I'm just going to substitute. That's a 4 minus 5 plus a c. So that's a -1. And it makes sense because the coordinates of c is 0 is to -1. So that line is minus x minus 1. That is the equation of BT. 4.5. If the coordinates of t are a is to b, calculate the values of a and b. I currently have two equations. I have the equation of AT, which is 4x minus 10, and I also have the equation of BT, which is -x minus 1. So you see the line TB and the line AT, they intersect at that point. At the point of intersection, these two are equal. So this is 4x minus 10, which is equals to minus x minus 1. That's going to be a 5, and that is going to be a 9. So x is 9 over 5, and then I just substitute in one of the equations. 9 over 5 minus 10, 4 into 9 over 5 minus 10. So I'm getting negative 14 over 5. So the coordinates of t are 9 over 5 is to negative 14 over 5. What is 9 over 5? It's 1.8. So 1.8. And then this coordinate right there is a 3. So yes, I'm expecting the value of a to be less than the x value there. And then the other one, negative 14 over 5, that's a 2.8, and that's a 2. So yeah, it is correct.